Today we're diving deep into the world of stacks. Whether you're prepping for coding interviews or just keen to strengthen your data structure knowledge, understanding stacks is crucial. Let's get right into it. What exactly is a stack? Imagine a pile of plates. You add a plate to the top, and you take a plate off from the top. This last in, first out principle is the essence of a stack. The most recently added element is always the first one to be removed. Now, why are stacks so important? It's because they're straightforward yet powerful. You'll see them used in parsing expressions, managing function calls and recursive algorithms, and even in undo features in text editors. Before we dive into stack operations, let's talk about their efficiency. Stack operations have a time complexity of O of 1, which means they're really fast. Whether you're pushing an item onto the stack or popping it off, it happens in constant time. This efficiency stems from the fact that you're always working with the top element, so no iteration through other elements is needed. Let's visualize this with an example. Consider an empty stack. We push an integer, say 10, onto the stack. Now your stack has one item, 10. What if we push another number, 20, onto the stack? It sits right on top of 10. This last in, first out behavior is a key characteristic of stacks. Popping an item from the stack removes the top element. So a pop operation now would remove 20. Stacks aren't just theoretical. They have practical uses in real-world applications. For instance, they're used in browser navigation. For example, when you click the back button, call stack management in programming, tracking function calls, syntax parsing, like checking for balanced parentheses, and much more. Let's talk implementation. While there are multiple ways to implement a stack, two common methods are using arrays or linked lists. Using an array, you have a fixed size stack. This means you need to specify the size of the stack upfront. However, with a linked list, your stack can dynamically resize, which is a significant advantage. In both cases, the time complexity for push and pop operations remains O of 1. Remember though, managing the capacity of a stack is crucial. If you use an array and reach the maximum capacity, you face a stack overflow. With a linked list, this is less of a concern as it can grow dynamically. Stacks are a fundamental data structure with a wide array of uses in computing. Their simplicity, efficiency, and last in, first out nature make them an invaluable tool in a programmer's toolkit, especially come interview time. Next time you're faced with a problem that involves reversing items, nested structures, or sequential processing, think of stacks.